It's 9x, yeah. So exercise 12.3, just going through some more questions. The remainder when your function of x is divided by x minus 2 is 216 and x plus 1 is a factor. So that means that p of what? 2 is 216 and p of 1 or negative 1 equals what? Yeah. Okay, so just substituting those in. P of 2, that gives me 16a plus 8b. 15 times 4, that's 60. Plus 9 times 2 is 18. Plus 2 is 216. So anyone that's done it, 16a plus 8b equals, well, that's 80 minus 216 minus 80 is 136, equation 1. And p of negative 1, negative 1 to the power of 4, that's positive 1, that's just a. Negative 1, that would be minus b. Negative 1 here, that would be plus 1 for negative 1 squared, that's plus 15. Negative 1 here gives me minus 9, plus 2 is 0. And we have a minus b is 56 plus 2, 8, negative 8. They're your two equations. And I would do, I would substitute. I would write my second equation as a equals negative b plus 8 or b minus 8. In other words, a is b, take away 8. And sub it into equation 2. And you get 16 bracket b minus 8 plus 8b is 136. And we expand and solve. What do we get? 120 plus 8b is 136. It looks like 8b is, what do you get there? 200 and so b is 264 divided by 8, which is 24b, sorry, divided by 24 gives us 11. Okay, so that you know how to do, all right? So we've found A and B for part A. But the next part of the question, worked out what A is. A take away 11 is negative 8, therefore A is negative 8 plus 11, which is 3. So we've got that A is 11, no, B is 11, A is 3, therefore your function of x is 3x to the 4 plus 11x cubed plus 15x squared plus 9x plus 2. Function. Part B says divide that function by x plus 1. You know if you divide it by x plus 1, you're going to get another polynomial with power of what? X cubed. You know, and then it says, so if you do divide, you go like this, x plus 1 into 3x to the power of 4 plus 11x cubed plus 15x squared plus 9x plus 2. You know that you are going to get an x cubed polynomial, a polynomial of degree 3 as your quotient, because you know x times x cubed gives you your x to the power of 4. So all this is saying is when you're finished, write your function of x, which is this, equals x plus 1 times your quotient. That's all it's saying. Now, why is it called g of x? Because it's different. Every time you have a new polynomial, you have to give it a new letter. So this one is f of x. I just think they put g because it's the next letter of the alphabet. They'll call the next one g of x. And then they might call the next one, if you divide again, the h of x. But you can't call this one function of x and the answer to the division, which is the quotient to fx. It's got to be given another letter. But g of x means the same as fx. It's just a different polynomial. That's all it means. So let's divide. We've got 3x cubed. So it's 3x4 plus 3x cubed. We've got 8x cubed plus 15x squared plus 8x squared, 8x cubed plus 8x squared. Let me know if I'm doing something wrong. 7x squared plus 9x plus 7x, 7x squared plus 7x, 2x plus 2 plus 2, 2x plus 2 and 0. So it works. So therefore, it equals x plus 1 times G of x is just your quotient, which is 3x cubed plus 8x squared plus 7x plus 2. That's all it wants. So that's fx, that's gx. In part 3, they're just saying show that fx plus 1 is a factor of gx. In other words, show that it's a factor of that. Do you get it? In other words, if I want to keep factorizing, and we know it's going to be, p of 1 won't work. Do you know why? P of 1. We're not going to do p of 1. We're doing p of negative 1. But remember what I said yesterday? How do you know when p of 1 will work? When the coefficients add up to 0, but they don't. So they're saying show that that's a factor, x plus 1. We substitute p of negative 1, so into g of x. So what's this going to be? Negative 3. This will be plus 8. This will be minus 7. And that will be plus 2. And we get minus 10 plus 10. Great. 0. So therefore, x plus 1 is a factor. And now they want us to factorize. Now you can do long division again, or we can do our little method. What do you want to do?
I did your method.
Was it quicker?
Yeah.
So now we can say, do you want to do, or you can do long division, but let's practice my method. So 3x cubed plus 8x squared plus 7x plus 2. See, what we're doing is trying to factorize this. We know that x plus 1 is a factor. So what do I write here for the rest of it? Do I have a squared? Wouldn't I have a quadratic here? So that's got to be ax squared plus bx plus c. All right, you can see by inspection, we can already see what a and b are. Oh, no, don't do the squared. I'm just factorizing g of x. Please, I'm just doing this one. So I'm factorizing this, and when I'm finished, I will do x plus 1 squared when I write out the whole thing. All right? So for part D, I want to factorize this, and when this is done, I will write x plus 1 squared. I'm only trying to factorize the cubic at the moment, not the quartic. I'm just factorizing this bit. So A is what? 3. C is 2. So I've got x plus 1, 3x squared plus bx plus 2. All right, let's have a look. I don't mind if you do the x term or the x squared term. Which one do you want to do? X squared or the x term? I'll do x squared. 8x squared. You're going to have to find it 2 places. It would be this, the 1 times the 3x squared, do you see it? And the x times the x. If you did expanding, if you expanded, you would only get that x squared term 2 places. So we've got 3x squared plus bx squared. You can already tell me what b is. 5. So therefore, the cubic factorization is that. Therefore, the whole factorization, which is the 3x4 one, see, I've just factorized that. This cubic here is x plus 1 that, but I may as well just keep going here. Not done. 3x, x, let's hope it factorizes. What do you reckon? 2? No, it's not. It's 1 and 2, because they're both plus. 3x squared plus 3x plus 2x plus 2. Lovely. So the cubic is factorized, but the whole thing is a quartic polynomial. Look. Oh, that's just an x. Now I can say it's x plus 1 times all of this. Oh, it's x plus 1 cubed. Look how many there are. Do you see? All right, I'll write it all out. X plus 1 times x plus 1 times 3x plus 2 times x plus 1, which is, wow, x plus 1 cubed times 3x plus 2. Oh, now you can draw it. Wouldn't that be fun? How do you draw it? What type of root? You got a triple root. Triple at x is negative 1. And you've got a single root at negative 2/3. I'm going to draw it while we're here. It doesn't say to, but I want to. See, a triple root and a single root. -1, -2/3. Make sure you know which one's lower. There they are. It's very spread out, all right? Where do we bounce off? Which one? And is it a positive quartic or a negative quartic? So that's a W, an upwards W. It should go like this. No, what's wrong with me? No bouncing. Inflection. Inflection. And then come up through there. But how are we going to check? Let's just substitute -2. Got it? Or, you know what's even better? Instead of substituting -2, stop. Why don't we just substitute 0? Because 0 is +2, it's up there. You don't even have to substitute. See, x is 0 is over here somewhere. That works too. You can do either end. Otherwise, it would have come that way and then like that. Okay? Triple root there and a single root there. And it sort of is the 4, but the second bit, 1, 2, 3, 4. When it's a triple root, you sort of lose the shape a bit. The second leg of the shape is flat, sort of. Not flat, but an inflection. 5 times x minus 2 is a factor. You would just do p of -5 to show that x plus 5 is a factor. So p of -5, that's -5 to the power of 4. I think that's positive 625. -5 cubed is -125, so that's -1250. 23 times 25, it's 625. It's 575, I think. Check it. Yeah, 34 times 5 is 170. All right. Right, so what do you get for that? We're hoping you get 0. And then the p of 2 is 8 plus 2 cubed is 8. 80. No, yes, plus 23 times 4, 4692. 34 times 2, 68. And we're hoping that that's 0. Minus 188. 88. Ooh, something wrong. Something is wrong. Made a mistake. Oh, look at that. Thank you. 2 to the 4. So that looks better. So that's 0. So therefore, so I can say here, therefore x plus 5 is a factor. Do you know what I mean? Therefore, x minus 2 is a factor. And we should be able to say, therefore, x plus 5 times x minus 2 is a factor. See, the factor theorem only works for linear factors. You can't go multiplying that through, get a quadratic expression, and use, oh, yes we can. Yeah, oh, no, we could. No, you can't, because it's got to be in the form, sorry, x minus a. That's the only way you can substitute into that equation to use the factor theorem. Do you get it? So show that x plus 5 is a factor, show that x minus 2 is a factor. Just like a factor tree, you can then multiply the factors to say that you've got new things that are factors. All right? Now, write function of x as a product of its linear factors. You've got 2 options here. I'd just go with the one option. Girls, it's going to be 2. What you need to do is expand this and you get x squared what? Minus 2x plus 5x plus 3x minus 10. If you want to write function of x as a product of its linear factors, you need to do the long division. But don't try and long divide with x plus 5x minus 2 as your divisor. You need to divide it by the quadratic x squared plus 3x minus 10. That's what you use as your divisor. Into x to the power of 4 plus 10x cubed plus 23x squared minus 34x. Now, I wouldn't use our other method of trying to guess because you've got 2 unknown factors, not 1. I mean, you could actually. We can do it with the other method, actually. I'll show you when we're done. We can do long division. Do you want me to leave that and you do it later? I want to show you another way. You know the other way is to do this, watching. That might take a while. It's to do this. x4 plus 10x cubed plus 23x squared minus 34x minus 120 is x squared plus 3x minus 10 times, instead of writing the linear factors, why don't I do, I'm just showing another way, ax squared plus bx plus c. Instead of doing the long division, just by looking, you can tell me what a and c are. So instead of doing the division, you're going to end up with a quadratic here, right? If you do the division, you will. You'll end up with a quadratic. But I can end up with the quadratic by doing this inspection. Now, the only reason I'm doing this, it's monic or it's a prime number here. And so what have I got? What's A? 1. What's C? Positive 12. Well, nearly there. And we need what B is. Now, this one's a little bit, we've got to get all the combinations. What do you want to go for? The x term? Let's just go for the x term, yeah? Let's do minus 34x. You don't have to do the x cubed term, the x squared term, and the x term. Just one of them will do. Let's go for the x term. How can you get x? You'd have to multiply 3x here by what? The constant? It's the only way you'll get it for that. But how else can you get it? Do you know why I didn't go for the x squared and the x cubed? Too many combinations. I'm going to go for the x one. 3x times the constant. Where else? Minus 10 times bx. That's it. If you go for x squared, I'm going to have to do the constant times the x squared and the x times the x. Twice for each one. Too many to do. Do you see? If I did the x squared, I'd have to do x squared times 12. But I'd have to do, oh no, the x times the x. Is that it? No, I'd have to do negative 10 times x squared as well. So I just didn't want to go near the x squareds. Too many combinations. So what have I got? Negative 10 bx plus what? 36x? What have I got? Well, I've got negative 34 is 36 minus 10b. What's that? B is a fraction. Whoa! Something's wrong. Oh, yeah, sorry. What's wrong with me? Yeah, so 10b, sorry, is 36 plus 34. That's better. Just can't solve equations. B is 7. Got it? B is 7. So it's x squared plus 3x minus 10, x squared plus 7x plus 12, which is easy to factorize. Let's just write the whole thing factorized now. What do you got? We know what the first one is because we just stuck it together. X plus 2x minus 5. This is x plus 2. Yeah, two numbers that multiply to give 12 but add up to give 7 are 4 and 3. Look, you can do the long division if you want. All right, and we left space to do it. So if you do the long division, you would get x squared plus 7x plus 12. You would get that. I've just shown it up there. If you do that long division, you will get that, and then you'll factorize it. But do you know why I put it as x squared, x squared? It's otherwise too hard to solve with all single factors. It's be impossible. Quadratic times quadratic gives you quartic power of 4. Pretty identical to what we did in question 12, just the wording's a bit different. You know, they told you before it's got these factors, x plus 5, x minus 2, or whatever it said. Here it's just saying it's got zeros, negative 3 and 4. So these zeros of the polynomial, the zeros of the polynomial are the roots of the equation. So therefore it has roots, negative 3 and 4. Therefore it's got factors of x plus 3, x minus 4. You know, because you do x minus a, whatever the root is. Because you have to do x minus a, where a is the root. Where a is the root or the 0. That's what the factor is. The factor will be x minus whatever the root or the 0 is. So it's x minus negative 3, x minus 4. So if you want to find, if you have to do the division, we're going to have to expand this to what we did before. All right? So x plus 3, you know what to do now? You're going to do it by inspection. Minus 4x plus 3x is minus x minus 12. You're going to divide x squared minus x minus 12 into the original polynomial, either using long division or by inspection. You know what I mean by inspection? What we just did, where I put the quartic to the power of 4 equals that quadratic times ax squared plus bx plus c. Work out a and c easily, work out b by inspection. Like by, I think it's quicker, but you can divide if you want. But once you finish dividing, you still have to factorize. Therefore, x to the power of 4 plus 3x cubed minus 13x squared minus 51x minus 36 is your quadratic that we have. And the other one has to be to the power of 2, doesn't it? Because power of 2 times power of 2 is power of 4. So ax squared plus bx plus c. What is a? A is 1. What's c? Positive 3. Beautiful. And we're going to do just the x term again because it's easier than doing x cubed, x squared. See, x cubed has to come from x squared times x. And just x times x squared, look, it would be all right. I don't know. You can do another one. Which one do you want to do, the x term or something else? I'm fine with whatever you choose. Oh, actually, I think I did something wrong in the other one. No, I didn't. All good. What do you want to do? Equate the x's, the x squareds, or the x cubed? The x. So minus 51x is, where do we get x from? X times the constant times the x. Only 2 places. So I've got what? Negative 12bx minus 3x. So therefore, 12bx is 51x minus 3x. 12bx is 48x. I can see what b is. It's 4. And you're done. But we still have to factorize. And the first one's already been factorized for you. And the last one's nice and easy to factorize as well. So the first one was already factorized to be x plus 3x minus 4. And the second one, easy. 2 numbers that multiply to give 3 but add up to give 4 are plus 1 and plus 3. So you can write it as a double root x plus 3 squared times x minus 4 times x plus 1. And geez, even if you wanted, you could graph it. U equals u cubed minus 13u squared plus 39u minus 27. Adding the coefficients, we realize they equal 0. Therefore, f of 1 will work. So that's 1 minus 13 plus 39 minus 27, which is 0. Therefore, what's a factor? Therefore, x minus 1 is a factor. And now we can, sorry, u minus 1 is a factor. U minus 1. So now we can write it as a product of its factors. We don't have to divide. We can just do our method. U minus 1 times what? You know, you can write a, but you can just start writing it. You can do u squared. Can you see it? And plus 27 straight away if you want. Or we can do a u squared plus b u plus c, which is u minus 1 u squared plus bu plus 27. Right? Now we just got to work out what b is. What have we got? U minus 1 u squared. All right, b. I don't mind which one you do. The constant, well, let's do the u. 39u is, how do we get u? Sorry, I shouldn't put this here. You get u times 27. It's 27u. And you get negative 1 times bu minus bu. All good? What's that? Well, it's got to be negative 12, doesn't it? Because it's 27 plus 12 is 39. Bu is 27 minus u minus 39u. So b is negative 12. Minus 12u plus 27. And factorize. minus 3 minus 9. Good. So the next question is to solve that thing. Now, what we're going to do, I've got to get this down here to look like that. So what is u going to equal? I've got to have u cubed. So that should look like, so 3 to the 3x minus 13 times 3 to the 2x plus 39 times 3 to the x minus 27. Isn't that 3 to the x cubed minus 13 times 3 to the x squared? See, this is 13 times 3 to the 2x. That 2x came about by multiplying 2 times x or x times 2. I'd rather put the x in the bracket. Plus 39 times 3 to the x minus 27. Now compare that with our original polynomial. What does 3 to the power of x equal? U. What does 3 to the power of x equal? U. 3 to the power of x is u. Can you see it? That's why I had to write it that way. So, therefore, if that's equal to that, if you let u equal 3 to the power of x. Okay, now we've got to solve this. We're going to put what that u is in here. All right, now, they're times. Those dots are times. Okay, so do brackets instead. Do you get why I have to make this look like that u cubed minus 13u squared plus 39u? You can sort of see what u is going to be when you look at the third term. U is going to be 3 to the x. So you have to have 3 to the x in each of them. 3 to the power of x in each of them. So 3, see, do you remember we've done stuff like this before? 3 to the 3x is either 3 to the 3 to the power of x or 3 to the x to the power of 3. And do you see why the second option's better? Because it'll work in each of them. Yep. So we let u equal 3 to the x and we substitute it up here. Now remember this, we put this equal to 0 up there. All right, I need to go over the page. Sorry. Let me just... So we're trying to solve that. So I should put my equal 0 here. If we let u equal 3 to the power of x, what I'm trying to solve is u cubed minus 13u squared plus 39u minus 27 equals 0. But I've already factorized that up here. So that's like solving u minus 1, u minus 3, u minus 9 equals 0. So I'm trying to solve that. Right? I put it all in terms of 3 to the power of x. I've let u equal 3 to the power of x and ended up with that. In the first part, I factorized that, so I've now factorized that. And so therefore, what does u equal? U equals 1, 3, or 9. Do you get it? So therefore, 3 to the power of x equals 1, 3 to the power of x is 3, or 3 to the power of x is 9. So you can tell me what x is. 0. Anything to the power of 0 is 1. X is 1. Or x is 2. So therefore, solving for x, we get x is 0, 1, or 2. The binomial is divided by 2x plus 1 times x minus 3. The remainder is 3x minus 1. And the question is, what is the remainder when the polynomial is divided by 2x plus 1? Okay, we're going to write the division transformation. So if your polynomial is divided by that and the remainder is this, do you remember how we do it? Your polynomial equals this. You know how it's ax times qx, remember, plus rx. Just think, your polynomial is that thing you're dividing times the top quotient plus the remainder. So your polynomial, I have no idea what the polynomial is. So p of x is, what's it divided by? That, 2x plus 1 times x minus 3 times the quotient. I don't know what the quotient is, but the remainder is 3x minus 1. It's slightly different to the one we did before, right? All right, what could you do from here? What could you sub? What could you sub to start working out? When I sub x is 3, so I'm going to do p of 3. Do you know why I'm doing p of 3? It wipes it out. P of 3, actually, you know, to answer the question, I just do p of negative a half. That gives me the remainder. So, P of 3, I'm going to do it, but it's not going to give me anything. But P of 3, you know, if you do P of 3, doesn't that give you the remainder when you divide by x minus 3? Remember? Yeah. So let's just do P of 3. What do you get? Isn't that 0? 0. You get 9 minus 1, you get 8. P of 3 is 8. So this means, therefore, if you divide by x minus 3, you will get a remainder equal to 8. That's what it is. That's the remainder theorem. But you're trying to divide by 2x plus 1, by this one. So what do you do if you're dividing by 2x plus 1? P of negative a half. You know, if you're dividing by 2x plus 1, you put that equal to 0, x is negative a half. So the P of negative a half is, now if you put negative a half in here, doesn't that wipe that out to be 0? It's 3 times negative a half minus 1. Negative 1.5 minus 1 is negative 2.5. So therefore, if you divide by 2x plus 1, the remainder is negative 2.5. Done. Do you get it? It's using the remainder theorem. You know how if you are dividing by x minus 2, you put p of 2 in and it gives you the remainder when you divide by x minus 2. Remember? Needed. I didn't need to do that. I just did it. So that, I would do that if they said what is the remainder when the polynomial is divided by x minus 3, I would have done this one. Because if you want to divide by x minus 3 and get the remainder, you do p3. If you're dividing by 2x plus 1, you do p of negative a half. Because it's got to be in the form of x minus a. You know how it's got to be in the form of x minus a?
Yeah. What about if you're trying to find a polynomial?
You'd have to come up with some, that's not what the question is, to